Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here once again we are going to apply the concepts of beta and gamma functions to evaluate this integral. So here we have to evaluate this integral from 0 to 1, and we have x raised to 4 divided by the cube root of 1 minus x cube square, right? So let us call this integral as I, and let us start with the method of substitution, right? Because our aim is to convert this integral into the beta function, that is beta m comma n is equal to the integral 0 to 1, and we have t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So the first step is to convert this integral into the beta function by a method of substitution. So now let us substitute here. X cube is equal to t, right? So here we'll introduce this variable t such that x cube is equal to t, or x is equal to the cube root of t, right? So let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 3, and using the power rule for differentiation, we know that the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here n is 1 over 3, so we have 1 over 3 t 1 over 3 minus 1, and this is 1 over 3 and t, and here we have 1 minus 3 over 3, that is 1 over 3 t, and minus 2 over 3. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us change the limits accordingly. So here the lower limit is x is equal to 0, and the upper limit is x is equal to 1. So when x is equal to 0, then the value of t can be obtained from this expression. So we have x is equal to 0, so 0 cube is 0, and when x is equal to 1, then the value of t is equal to 1 cube, that is equal to 1. So when x goes from 0 to 1, then t also changes from 0 to 1. So now we can easily write this integral I in terms of t. So we have t is equal to 0 to t is equal to 1, and for x we can write t raised to 1 over 3 raised to 4, and here we have x raised to 4, so taking x is equal to t raised to 1 over 3, and then we have the cube root of 1 minus x cubed square. For x cube we can write t, and here we have square, and for dx we can write 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us simplify this integral. So now we can write this integral I as 0 to 1, and here we can take this term 1 over 3 outside the integral. Then we have t raised to 4 over 3. Here we have t raised to minus 2 over 3 dt, and in the denominator we can write 1 minus t square, and here we have the cube root, so here we can write 2 over 3. So now this is 1 over 3 0 to 1, and here using the laws of exponents, we can write t raised to 4 over 3 minus 2 over 3, that is t raised to 4 minus 2 is 2, so this is t raised to 2 by 3. So here we have t raised to 2 by 3, and taking this term to the numerator, we have 1 minus t raised to minus 2 over 3 dt. So now what we have to do, if we see this integral and this integral, then we can easily conclude that here we have m minus 1 and here we have 2 over 3, and here we have 1 minus t raised to n minus 1, and here we have 1 minus t raised to minus 2 over 3. So let us write this exponent, that is 2 over 3 is equal to m minus 1, right? So we can solve this equation. So we have m is equal to 1 plus 2 over 3, that is 3 plus 2 over 3, that is 5 over 3. And similarly here we have minus 2 over 3, and here we have n minus 1. So solving this equation for n, we can now write minus 2 over 3 plus 1. So this is minus 2 plus 3 over 3, that is 1 over 3, right? So now we can write this integral as 1 over 3, 0 to 1, and t raised to 2 over 3 can be written as m minus 1, right? Because we want to convert this integral into this form. So 2 over 3 is equal to m minus 1 and m is 5 over 3. So we can now write t raised to 5 over 3 minus 1, because 5 over 3 minus 1 is again 2 over 3. And then we have 1 minus t raised to minus 2 over 3, and n is 1 over 3, so minus 2 over 3 is 1 over 3 minus 1, and here we have dt, and 1 over 3 minus 1 is minus 2 over 3. So now this integral is similar to this one, that is this is the beta function. So now we can write 1 over 3, and this integral is equal to the beta function, that is beta m comma n. So here m is 5 over 3 and n is 1 over 3. So now we have to calculate the value of this beta function by using the relationship between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So now this integral I is equal to 1 over 3, and beta 5 over 3 comma 1 over 3 is equal to gamma 5 over 3. Then we have gamma 1 over 3, and here we have gamma 5 over 3 plus 1 over 3, right? So this is 1 over 3 and gamma 5 over 3, and then we have gamma 1 over 3, and here 5 plus 1 is 6, 6 over 3 is 2, so we have gamma 2. So now to get the value of gamma 5 over 3, let us make use of this important result, that is gamma n plus 1 is equal to n times gamma n, right? So if we take gamma of 5 over 3, then gamma 5 over 3 can be written as, here we can write 2 over 3 plus 1. Right? So we can split 5 over 3 as 2 over 3 plus 1. So if we compare this expression with this one, then n is 2 over 3. So here we can now use this expression. So we have 2 over 3 times gamma 2 over 3. And gamma 2 is equal to 1, because we know that gamma n plus 1 is equal to n factorial when n is a positive integer, right? So gamma 2 can be written as gamma 1 plus 1, and that is 1 factorial, that is equal to 1. So now we can write this expression as 1 over 3. Gamma 1 5 by 3 can be written as 2 over 3, gamma 2 over 3, and then we have gamma 1 over 3, and in the denominator we have 1. So now here we can multiply these two fractions. So we have 2 over 9, and then we can now write this 2 over 3 as 1 minus 1 over 3, right? So the purpose of writing 2 over 3 as 1 minus 1 over 3 is to make use of the famous Euler's reflection formula. So gamma 2 over 3 can be written as 1 minus 1 over 3, and here we have gamma 1 over 3. So now let us look at this expression. So we know that from Euler's reflection formula, that is gamma 1 minus n times gamma n is equal to pi over sine n pi, right? So if we take n is equal to 1 over 3, then this left hand side it appears as 1 minus 1 over 3. Then we have gamma 1 over 3, and here we have pi over sine n pi. So n is 1 over 3, so we have sine pi by 3. So now we have pi, and sine pi by 3 is sine 60 degrees, that is root 3 over 2. So we can now write 2 pi over square root of 3. So now the value of the integral I is equal to 2 by 9 times gamma 1 minus 1 over 3 times gamma 1 over 3, and the value of this expression is equal to 2 pi over square root of 3. So we can now multiply 2 and 2 pi, so we have 4 pi over 9 root 3. So viewers, the value of this given integral is given by 4 pi divided by 9 times square root of 3.